In this section, we're going to look at solving exponential equations. The methods to do this are always to try to make the bases match first, because if the bases match, we can use the property that says if u to the x is equal to u to the y, then x has to equal y. Or what this property says in layman's terms, if we can make the bases match, we can forget about the bases and just set those exponents equal to each other. If the bases don't match, you're going to have to take the log of both sides, because we have the exponent property that says if we have the log of a number to a power, we can pull that power down in front of that logarithm, and that will get rid of the exponent that way. Let's jump into an example. We'll start with an easier one that says 2 to the x is equal to 32. We want to try to make the bases the same. You should know 2 squared is 4. You can use your calculator to help you find the following. 2 to the third is 8, 2 to the fourth is 16, and 2 to the fifth is actually 32. So we can rewrite this as 2 to the x is equal to 2 to the fifth, and we get to use that property that says if u to the x is equal to u to the y, then x equals y. That's going to help us and say that the exponents are now set equal to each other, and x has to equal 5. Let's look at a problem similar to that. If we have 4 to the 3x minus 5 power set equal to 16, we want to try to make the bases the same. The left side has the base of 4. Can we make the right side have the base of 4? And we say yes, we can, because we know that 16 is really 4 to the second power. By using that property, if u to the x equals u to the y, then x equals y, that's going to tell us that 3x minus 5 has to equal 2. In solving that, we just add 5 to both sides. That's going to tell us that 3x will equal 7. Divide both sides by 3, and x is going to equal 7/3. You can easily check this problem going back into the original equation, looking at the left side. 4 to the 3 times 7/3 power minus 5 is really the same as 4 to the 7 minus 5 power, or 4 squared, which is equal to 16. So left side is going to equal right side. The problems will get increasingly more difficult, and we'll have problems where we cannot make the bases the same. For example, if we have 2 to the x equals 40, we said in the last problem that 2 to the fifth is actually equal to 32. If we look at 2 to the sixth power, that's going to be 64. So we cannot make 40 into a nice round number of 2 to a power. In that case, we're going to take the log of both sides. If we take the log of both sides, algebraically it's equivalent as long as we do the same thing to both sides. And then we can look and see that we have the power rule. And remember, the power rule says if we have the log of a number with a power, we can pull that power down in front of that logarithm. So we're going to do that on the left-hand side. X times the log of 2 is going to equal the log of 40. Now to solve for the x, it's attached to this logarithm of 2 by multiplication. So I'm going to divide both sides by the log of 2. And that's going to give me x will equal the log of 40 divided by the log of 2. We'll pull our calculator up and have the calculator actually solve that for us. If we punch the log of 40, closing the parentheses for that logarithm, divided by the log of 2, that's going to give us the answer of 5.322 if we round it. So x is going to equal 5.322. Notice that the x is in between the 5 and the 6, because we said 2 to the 5th is 32 and 2 to the 6th is 64. To check our answer, if we want to plug that in, we can say 2 raised to the 5.322 power should equal 40. Notice it doesn't equal 40 exactly because we had to round. If you want to get the exact answer, we can punch the log of 40 divided by the log of 2 back into our calculator, get that exact value without rounding, and then say 2 raised to the answer, which you get by hitting second negative sign that the calculator just got, and that's equal to 40. So you can check your answer that way. Let's look at another problem. Let's look at 28 to the x power is going to equal 10 to the negative 3x power. We can't make those bases the same, so we want to take the log of both sides. This time I'm going to use natural log. The natural log of 28 to the x equals the natural log of 10 to the negative 3x. You can use a common log or a natural log as long as you're consistent on both sides. Once we have the log of both sides, I'm going to use that new or the old property we have that says if I have the log of a number to a power, I can pull that power down in front of the logarithm. So x times the natural log of 28 is going to equal negative 3x times the natural log of 10. Once the exponents are down, we can solve this just like an intermediate algebra equation. We get the x terms to the same side by adding 3x natural log of 10 to both sides, which is going to give us x times the natural log of 28 plus 3x times the natural log of 10 will now equal 0. Factor out the x times the natural log of 28 plus 3 natural log of 10 is going to equal 0. Now to solve for the x, all we have to do is divide both sides by the parentheses, and that parentheses is going to be the natural log of 28 plus 3 natural log of 10. And we see at this point 0 divided by anything is 0, so in this case x is going to equal 0. If you actually wanted to plug that into your calculator, we would type 0 divided by parentheses, the natural log of 28, closing the parentheses for the natural log, plus 3 times the natural log of 10, closing again for the natural log, and then closing for the bottom. And you'll notice that that does give us 0. Let's look at two more examples. Let's look at something like 2 to the x plus 1 equals 5 to the 2x, where we can't make the bases the same. So again, we want to take the log of both sides. I'm going to use natural log. I like natural log because it's shorter to write than actually the common log of log. Once I take the log of both sides, I do that so I can pull the exponents down in front of the log. That's going to give me x plus 1 times the natural log of 2 will equal 2x times the natural log of 5. Notice on the left-hand side, I put that in parentheses because it's more than one term. I'm actually going to have to use the distributive property. I'm going to have to say x times the natural log of 2 plus 1 times the natural log of 2 will equal 2x times the natural log of 5. At this point, I have x's on both sides. I need to move them to the same side. The quickest way to do this is going to be to subtract x natural log of 2 from both sides, which will leave me 1 times the natural log of 2, or just the natural log of 2, equals 2x times the natural log of 5 minus x times the natural log of 2. Both terms have an x in them, so I want to factor that x out. X times 2 times the natural log of 5 minus the natural log of 2 will equal that left-hand side of the natural log of 2. At this point, the only thing we have to do to solve for the x is divide both sides by that parentheses. So that's going to give us that the natural log of 2 divided by 2 natural log of 5 minus the natural log of 2 is going to equal our x. Now this can get a little bit sticky in the calculator, so let's look at how to put that in the calculator. Let's move this over a little bit. You want to put the natural log of 2 and close the parentheses. That's going to be your numerator. divided by, since this is more than one term, we're going to have to use parentheses, the quantity of 2 natural log of 5, closing for the natural log of 5, minus the natural log of 2, closing for the natural log of 2, and then closing for the denominator, is going to give us 2.74, or excuse me, 0.274 as our answer. You can kind of do a check in your calculator if you'd like to and make sure that that works. At this point, we have one example left. This one's not going to be near as difficult. Let's look at e to the t equals negative 0.08. What we try to do is make the bases the same, which we cannot make those bases the same, but we can take the log of both sides. If you will use the natural log on this, you should remember the property that says if the base matches the number next to it and there's an exponent, then the answer is just going to be the exponent. In this case, the natural log has the base of e, so the base matches the number next to it. We can just say that our number is going to equal the natural log of 0.08. You can punch that in your calculator. Natural log of 0.08, closing your parentheses, and it will tell us that t is going to equal negative 2.526. Good luck on this homework.